Hello everyone, welcome back to the channel. In the last video, we looked at common error types in Python: syntax errors, runtime errors, and logical errors. Today, we are going to take the next step and learn how to actually handle errors gracefully so that our program doesn't just crash. For that, Python gives us a very powerful tool, the try, except, block. Normally, when Python hits an error, it stops everything and shows an error message. That's fine for learning, but in real programs, we want to handle errors more gracefully. With try, except, block, we can tell Python, try running this piece of code. If something goes wrong, don't crash. Just do this instead. So here's the general structure. Try running this code that might cause an error. If something goes wrong, except, don't crash. Instead, try running this code. So let's look at some practical examples. We will start with a simple case. Let's divide 10 by 0. Normally, this causes a zero division error. But instead of letting Python crash, we will catch it and print our own message. So this is what we tried last time. When dividing 10 by 0 and printing the result, Python crashes and throws an error message, zero division error. But what we would like to have, we would like basically to have Python to not crash and instead printing something else. So try let's make it more interactive. So we would like to print a message like this one, for example. Oops, division by 0 is not allowed. So what we expect, if division worked, it should print the result. What actually happens, division by 0 fails, so the except block runs. Let me run this, and since the division by 0 fails, this block, the except block, runs. Now let's try printing a variable that doesn't exist. Normally Python would stop the program with a name error message. With try except, we can handle it ourselves. So basically this is actually what we did last time as well. For example, print x. So there is a name error message here. We try try except block, we can handle it ourselves. So basically I would like to have another message here like print the variable x is not defined. So what we expect, if x existed, it would print the value of x. What actually happens, since x is not defined, the except block runs. Let me do that. And since x is not defined, this block, the except block, runs. Sometimes we want to handle different errors in different ways. We can do that by naming the specific error type. For example, zero division error or name error. Now let's see how it works. We will work on the previous examples. For example, try ten divided by 0, print result except if zero division error, if you encounter zero division error, print caught a zero division error. In the other example, try print y except name error. If you encounter name error, print caught a name error. So let me run this. So in the first block here, the division fails with a zero division error. So the output is caught a zero division error. In the second block, the variable y is not defined, it is undefined, causing a name error. And since we encounter a name error, basically the output would be this line, caught a name error. This is better practice than just using a plain except, because it makes debugging clearer. You know exactly what type of error was caught. Python also lets us use two more blocks with error handling. Else, so this runs only if no errors happen in the try block. This is useful when you want to separate the code that should run only when everything goes smoothly. And finally, this runs no matter what, whether there was an error or not. This is great for cleanup tasks. For example, closing files, disconnecting from a database, or simply confirming that the program has finished that section. Let's put this into practice. We will ask the user for a number, then divide 10 by that number. And this is what happens. If the user enters a valid non-zero number, the division works and the else block runs. If the user enters 0, a zero division error occurs and the except block runs. The finally block runs no matter what. So let's practice that. In this line, I am asking the user to provide a number, to enter a number. It could be any number. Then try result 10 divided by the number, print result except zero division error print division by 0 is not allowed. Else print no errors, division was, for example, successful. Finally, no matter what, basically this line will be executed. Finally, print this block always runs. So let me run this, and let's say that we enter 2 and 10 divided by 2. So basically it should work fine. Let me do that. So and basically we enter the number, that's 2. The result is 10 divided by 2, 5. So basically no error. Since we didn't have any error, this line except is skipped. The else block runs. This block runs, confirming success. Then finally this block runs at the end. Now let's try something else. Let me do, for example, 5. It should be the same, so everything works fine. So this block runs, we skip this block, and basically this block runs, and no matter what, this block runs as well. What if I enter 0? So basically 10 divided by 0, it cannot print the result, and except it encounters a zero division error, so this block runs, except block runs, and it prints division by 0 is not allowed, and basically this block, no matter what, this block runs anyway. You can also do other numbers like this one and try some other numbers as well. So to summarize today's lesson, try except block lets us handle errors without crashing our program. We can catch all errors with a general except, or catch specific errors like zero division error or name error. Adding else gives us code that runs only when the try block succeeds, and adding finally guarantees that some code always runs whether there is an error or not. So this approach makes Python programs more reliable and professional. Thanks for watching this video on Python's try except blocks. If you found this lesson helpful, please like the video, share it with your friends, and subscribe so you don't miss future Python tutorials. Also check out my other videos on common error types, debugging strategies, and working with real datasets. See you in the next one.